Hi, I'm Ms. Vung. Today we're going to look at families of functions and transformations using the CAS calculator. Example 1. For the function f of x equals x minus 3 cubed x minus b, where b is a positive constant greater than 4, find the derivative of f of x with respect to x. So here we have the CAS and we are in main. We're going to write down the expression we're working with, so x minus 3 close bracket to the power of 3, and then x minus, we go to keyboard variable to obtain our b. Get rid of keyboard so we have more space to see, and close bracket, enter. So now we have our original equation. We can define it or we can just drag and drop. I prefer dragging and dropping, so that's what I'm going to do today. Now the derivative is in action and in interactive. I prefer using action. They do the same thing. So go to calculation, diff for derivative, drag and drop it in there and hit enter. And we have our derivative. Now this looks really scary. We can click on simp up here and it will simplify our derivative. So here we have our original equation and we have our derivative in this line over here. So original up here, derivative there. You can define it, but I prefer using it this way. Part B, find the coordinates of the stationary points of the graph. So the stationary points of the graph occur when the gradient is 0. So let's do that. So let this equation equal to 0 and we have to solve it. Where do we find solve? In actions, advanced, solve. So we have to let this, the derivative equals to 0. Enter. So now we have our x values for when the gradient is 0. How do we find our y value? We substitute these in our original equation. So that's our original equation. I'm just going to drag and drop. And you can click on shift comma, which is a shortcut to bring out that bar, and we can let x equal to whatever we want. In this case 3, so I can just highlight, drag and drop, enter. And we do the same for the other x coordinate. So I'm going to copy this section and x equals, copy that section over there, drag and drop, enter. Again, that looks a little bit scary, so we click on simplify, so we have a nicer y value. So when x is 3, we worked out that the y value is 0, and when x is that monster, the y value is minus 27, b minus 3 to the power 4 over 256. Let me write that down. So we have the coordinates of the stationary points. Part C, show that the stationary point at 3, 0 is always a stationary point of inflection. What does that mean? Always a stationary point of inflection means that the gradient there is 0, but before it and after it is both positive, or before it and after it is both negative. If it is different, then it will be a maximum or a minimum. Now we have to go before and after 3. We're going to do plus and minus 0.1. So 3 minus 0.1 is just before it, and 3 plus 0.1 is just after 3. You might have noticed that in previous examples in videos we did minus 1 and plus 1. Minus 1 and plus 1 does work, but sometimes the graph wiggles a lot and you need to zoom in to a closer section to see what kind of stationary point it is. If you zoom out too much, you might not see an accurate picture. So to be safe, use 0.1 whenever you have a calculator. And then if you want to have a look at it, we'll have a look at what it looks like later. So we have to find a gradient at 2.9. Let's go back to our CAS calculator. Where is the gradient equation? It's here. So we need to find the gradient. Oops, let me try it again. The gradient at, so shift comma, x equals 2.9. And then we do the same thing, the gradient at x equals 3.1. Okay, here we have the gradient for 2.9 and the gradient at 3.1. Now, if the gradient is 2.9, we can see that we have this. We know b is greater than 4. Now, 3 times 4 would be 12. 12 can be written as 60 over 5. We're just looking for a common denominator so we can compare. And 60 over 5 is definitely greater than 43 over 5. Now, if it's greater than 43 over 5, then this thing inside the bracket will always be positive. If this thing inside the bracket is always positive, then putting a negative in front of it will always make it negative. So the gradient at 2.9 is always negative. Likewise, we see 3 times b. b has to be at least 4. So 3 times b has to be at least 12. At least 12 is the same as saying at least 60 over 5. And 60 over 5 is definitely greater than 47. So 60 minus 47, which is smaller, will always be positive inside the bracket. Putting a negative in front of something always positive makes it negative. So the whole thing is also negative. So we can see that the gradient is negative on both sides. So we put it in a table to show that it's negative on both sides. So 3, 0 is a stationary point of inflection. Now, I did say that we're going to show you what happens if we had used plus or minus 1. So if we use minus 1, that would have been 2. And if we use plus 1, that would have been 4. And when you hit enter, you'll see that it is not always negative on both sides. Because when we put 4 into the minus 3b, we get minus 12. Minus 12 plus 13 is actually positive. So why does this happen? Let's have a look at the graph. Okay, so here we have the graph, x minus 3 cubed x minus b, where b is 4. We can see that we had used plus or minus 0.1. We went a little bit to the left to see that the gradient is negative, and a little bit to the right to see that the gradient is negative, and therefore it is definitely a stationary point of inflection. Had we gone too far, like minus 1 from 3, which is 2, it would be negative, but plus 1 from 3 at 4, it would be positive. Negative, 0, positive gradient would make it look like a local minimum. So instead of looking at what it is, which is a stationary point inflection, if we went too far, we might misunderstand and think it's a local minimum. So it's important, it's always safer to go really, really close, and therefore you get the gradient just before and just after rather than far away. So this is a good example so that you can be aware of the points you're picking, that they're close enough to the point that you're analyzing. Part D, find the values of B if the stationary points occur where x is 3 and x is 15. Now we know previously that these are the coordinates of the stationary point. So it's clear that the stationary point at 3 is 3, 0. So the other stationary point happens at x equals 15. So this 3b over 4 plus 3/4 is equal to 15. So now we can figure out what b is by letting that expression equals 15. So let's go to our calculator. I'm going to be lazy and look for that. So it's over there. And I'm going to drag and drop it down here so I can work with it. Let that equal to 15. And I'm going to solve that, but I'm going to solve for, it doesn't like B, the calculator, so I'm going to solve for Y instead. Interactive, advanced, solve, and this time I'm solving for Y instead, just using a different thing. So now we have Y equals 19, or in other words B, because we use Y instead of B. Anyway, so B is equal to 19. Example 2, the cubic with equation y equals ax cubed minus 3bx squared has a turning point with coordinates 1, 8. Find the values a and b. So what does it mean to have turning points at 1, 8? Turning point means the gradient is equal to 0 at x equals 1, and the equation is equal to 8 when x is 1. So now we have 2 equations and 2 variables, we can work it out. So let's find the gradient first. So I'm going to type in our expressions so that we can work with it. So go to keyboard, use variables, not ABC, use variables. So we have, what do we have? A x cubed minus 3b x squared. That's what we're going to work with. So we can find the derivative in calculation diff. So we have the derivative. There's a few ways to do this, but we know that the turning point is at 1/8. So let's substitute 1 into here. So shift comma x equals 1. That's the gradient at 1, and the original equation at 1 looks like that. So now we have to solve. We click on keyboard, oops, math 1, and we look for this symbol over here, and we put in our two equations. So the gradient is 0, so let it equal to 0 at that point, and our equation is equal to 8 at the turning point. And now we're solving for a comma b, and we have a equals -16 and b is 8. So recap, find the derivative using action calculation diff, and because we have a turning point there, the gradient is 0 when x is 1 there, and because the turning point is at 1/8, the equation at 1 is equal to 8, and we can solve using that function. Example 3. The graph of the function y equals x cubed minus 9x squared is translated by a units in the positive direction of the x-axis and b units in the positive direction of the y-axis. Find the coordinates of the turning points of this graph. So let's use our CAS. So the equation we're working now is x cubed minus 9x squared, enter. So we have to differentiate it to find the gradient. Now the gradient is equal to 0 at the stationary points, and if we solve for that, we'll get the x values of the two stationary points. Now that we have the x values, we have to plug it into our original equation to find the y value of the stationary points. Brought up the bar by clicking shift comma again. We have 0 as 0, 0 as our first stationary point, and the other one is 6 and -108. Find the coordinates of the turning points of its image. Now the image in the question, it states it has been moved a units in the positive direction of the x and b units in the positive direction of the y. So in other words, the x value has added a and the y value has added b. So now we have these points. So we have AB, because 0 plus a is a, 0 plus b is b, and 6 plus a, because we're adding a to the 6, and b minus 108, because minus 108 plus b is the same as b minus 108. Thank you for watching, and I'll see you next time. Bye!